The language we use for Arduino, called C++, has a few ways to simplify some operations by allowing us to jump from one part of the code to another. Like, for example, repeating a part of the code a determinate amount of times. To show some of these tools, I created this example sketch that I'll explain in detail, so maybe you can later use it in your own projects. As always, you can download this sketch in the description of this video. I added a lot of comments explaining everything, but let's go through the code to give you an idea of what those tools can do. First, in the setup section, we're going to demonstrate how the while loop works. Before starting with that, we print in the serial monitor this text. Then it creates this variable so we can use it. Now we create the while loop that is going to run everything inside the curly brackets until the condition inside the parentheses becomes false. When we first run this line, the variable is 0, so the condition is true, making it run the code that prints the value of the variable. Then we create a tab space, increment the variable by 1, and print the variable again. It's going to start from the beginning testing the condition again, and since the variable is now 1, which is less than 5, it's going to run the code once again, over and over until the variable is no longer below 5. When the condition is false, it continues running the code normally. That for this case, the next line is printing this text in the serial monitor. The next tool we show here is the do while loop. That is very similar to the while loop that we just went through, but the difference is that we test the condition after running the code inside the curly brackets. So even though the condition is false, it still executes this part of the code at least once. For example, the condition to run the loop is that the variable should be below 1, and the variable is actually 4, so it's not going to loop, but it still runs the code inside the curly brackets one time, as it's evident in the serial monitor. Continuing with the code, now we have the for loop. That is similar to the while loop, but it can create the variable, do the condition, and increment the counter all inside the parentheses, making it a very popular choice for creating loops. In this example, we print this text 4 times and then exit the loop. As you can imagine, this kind of loop can make the job easier when we need to do repetitive operations, like for example writing a character array in the EEPROM. In any of these loops, we can use the break to exit the loop. In this example, we have a for loop that should run 5 times, but we have a condition that if the variable is equal to 3, it's going to break the loop. That's why it stops printing the text in the serial monitor when the variable is equal to 3. There's a similar option called continue that will skip the rest of the code and continue the loop. In this example, we have the for loop printing the variable many times, but when the variable is equal to 3, it skips the rest of the code, not printing the variable, and continues running the loop. That's why in the serial monitor we don't see the number 3 printed. The difference between the break and continue is that the break exits the loop completely, when the continue only skips the following code inside the loop, but continues doing the loop. Next, in the example sketch, we show how to use the void. That is a part of the code outside the setup and the main loop that it never runs unless it's called into action. We have it here after ending the main loop, so it's like isolated. You need to give it a name, and optionally you can add variables so you can use it inside the curly brackets. In this case, we created the variable 7. If we run this void, it's going to print some text in the serial monitor and then prints whatever value the variable has. Now let's go to the setup section when we call this void by mentioning the name of the void and putting the value we want to send to the variable, that in this case is 24. That means that when we call this void, it jumps there, prints the variable, and comes back to where it was before, where the next line is printing this text. The void can have multiple variables or none, if that's what you want. Using voids like this is very useful when we need to repeat parts of the code in specific situations. But instead of copy-paste the code throughout the sketch, it's better to create a void and call it only when we need to run that piece of code. The final thing I'm going to show in this example is the switch case that is similar to the if-else that runs a piece of code only if the variable has a specific value. But the structure is a little different. Some people prefer it in some situations, but at the end you could do basically the same thing with if-else, so it's a matter of taste. To demonstrate how it works, we have in the main loop a variable increasing until the variable reaches 7. On each cycle, this is going to print this text in the serial monitor. And when the variable is equal to 2, it's going to print this other text. Same if the variable is equal to 4, it prints this text and continues running the main loop as usual. The variable eventually reaches the value 7, so it stops printing stuff to the serial monitor, but the main loop keeps running. In this case, it's not printing anything else since the conditions are not met, leaving the main loop running without doing anything. You see, it's not as complicated as it might appear. Keep experimenting, and when you feel ready, watch the next tutorial where we're going to talk about interrupts and how useful they can be on things that are timing critical, like when creating a tachometer. If you ever need to have a custom PCB for your projects, either your own design or from one downloaded from someone else, you can upload the Gerber files to PCBWay.com and they can manufacture it starting at $5 plus shipping. That makes it easier than using a generic prototype board. I hope it was helpful and see you in the next video. Bye bye.